Hello everyone, my name is Priyanka and I welcome you all to Study Room. So today we will be starting chapter 12 of class 9 science, that is sound. So let's get started. As you can see in this video that the birds are chirping, it is a type of sound, right? Me and you are talking, it is a type of sound. So sound is a kind of vibration, right? So what is sound? Sound is a form of energy which produces a sensation of hearing in our ears. Okay. So let's watch this video. So we are doing an experiment with tuning forks, right? Vibrating tuning forks. So in this we have produced sound by striking the tuning fork. We can also produce sound by plucking, scratching, rubbing, blowing or shaking different objects. Vibration means a kind of rapid to and fro motion of an object. The sound of the human voice is produced due to vibrations in the vocal cords. When a bird flaps its wings, do you hear any sound? That is also a type of sound. Activity on production of sound. So here we took a tuning fork and a glass of water. Okay. So what do we observe? We observe that, it is vibrating. So we take two cases, right? That sound is produced by striking the tuning fork, right? So this is one experiment where both the prongs of the vibrating tuning fork are dipped in water. So in case one of the prongs of the vibrating tuning fork touching the water surface, and in case 2, both the prongs of vibrating tuning fork are dipped in water. Okay, so what do we see? That they are vibrating. Okay. So vibration is produced and then hence a sound is produced. Okay. So propagation of sound. Okay. So what is sound? Sound is produced by vibrating objects. The matter or substance through which sound is transmitted is called a medium. It can be solid, liquid or gas. Sound moves through a medium from the point of generation to the listener. When an object vibrates, it sets the particles of the medium around it vibrating. The particles do not travel all the way from the vibrating object to the ear. A particle of the medium in contact with the vibrating object is first displaced from its equilibrium position. It then exerts a force on the adjacent particle, as a result of which the adjacent particle gets displaced from its position of rest. After displacing the adjacent particle, the first particle comes back to its original position. This process continues in the medium till the sound reaches your ear. Okay. So how does the sound propagates? Sound is produced by vibrating objects. The matter or substance through which the sound is transmitted is called a medium. It can be solid, liquid or gas, right? Right, I just explained this. So sound as a wave. So what comes in your mind when you think of wave? Wave, right? So we'll study sound as a wave. It is directly related to frequency of voice, pitch of voice. Okay, so have you ever done your voice recording? So you'll see that there is some graph which is going on in your voice recordings. What is this graph? This is basically a kind of wave, okay? So wave is a disturbance that moves through a medium when the particles of the medium set neighboring particles into the motion. Okay, so they in turn produce similar motion in others. So sound waves. Sound waves are characterized by the motion of particles in the medium and are called mechanical waves. So sound waves are a type of mechanical waves. Okay. See, so like your voice recordings have this form, this is the type of mechanical wave. So you'll notice that when you speak louder, your voice becomes very much, their height increases, right, in the wave. And when you speak soft, it's very feeble, right? So we'll study more about waves. So direction of wave, and it is a mechanical wave. Compressions and rarefactions. Okay. When a vibrating object moves forward, it pushes and compresses the air in front of it, creating a region of high pressure. This region is called compression. Okay. So when high pressure area is created, high pressure area, then it is called compression, which we denote with C. When the vibrating object moves backwards, it creates a region of low pressure area called rarefaction. Okay. So when low pressure area is created, then it is rarefaction. Okay. And we denote it with R. Can sound make a light spot dance? So let's do an experiment to learn more about this. Okay. Okay, so take a tin can, remove both ends to make it a hollow cylinder. Okay. Take a balloon and stretch it over the can. Then wrap a rubber band around the balloon. Okay. Take a small piece of mirror. Use a drop of glue to stick the piece of mirror on the balloon. Okay, stick this piece of mirror on the balloon. Allow the light through a slit to fall on the mirror. After reflection, the light spot is seen on the wall, as shown in the figure. Okay. Talk or shout directly into the open end of the can and observe the dancing light spot on the wall. Okay, so you will observe that dancing light spot on the wall. Why is this so? Due to the vibration, due to the sound. Okay. So a beam of light from a light source is made to fall on the mirror. The reflected light is falling on the wall. Okay. So the disturbance created by the source of sound is the medium, travels through the medium and not the particles of the medium. So let's see this. Here this girl is speaking in the medium. Okay. So we'll see how the sound travels in the different mediums. Okay, in different mediums. So how does the sound produced by a vibrating object in a medium reach your ear? Have you ever wondered? So when an object vibrates, it sets the particles of the sounding medium vibrating. The particles in the medium in contact with the vibrating object surface displace it from the equilibrium position. Okay. It then exerts a force on the adjacent particles. After displacing the adjacent particles, the first particle of the medium comes back to the original position. This process continues in the medium till the sound reaches your ear. So this is the whole process. Okay. This is how the sound is produced. Okay. Okay, so how does the sound produced by a vibrating object in a medium reach your ear? When an object vibrates, it sets the particles of the surrounding medium vibrating. The particles in the medium in contact with the vibrating object displace from their equilibrium position. It then exerts a force on the adjacent particles. After displacing the adjacent particles, the first particle of the medium comes back in its original position. This process continues in the medium till the sound reaches your ear. So it is basically due to vibration produced. Okay. Sound needs a medium to travel. So sound is a mechanical wave and needs a medium like air, water, steel for its propagation. Sound cannot travel without medium. Okay. So sound needs some medium to travel. So what does that mean? That it cannot travel through vacuum, right? So for example, if there is no atmosphere, there is no air, what is vacuum? No air and no atmosphere. If there is no air and no atmosphere, in that place your sound cannot travel. Okay. Bell jar experiment. So what do we see in this experiment? So we did this experiment to see that, if sound can travel through vacuum or not. So we did this experiment. We connected, we took a bell jar, connected an electronic bell within it. We placed a cork, okay, and for the electric connection. Okay, so what will we see that, if we'll, speak something from here, for example, I say hello from here, so no voice will come out from here, from the vacuum pump. Why? Because sound cannot travel through vacuum. Correct? So let's do some question. Explain how sound is produced by a school bell. Okay. The sound produced by the school bell is dependent on how the bell vibrates when it is hit. The particles of the medium start to vibrate when the bell is hit physically or mechanically. As the particles start to vibrate, there is a disturbance caused in the waves. Right, when the bell moves forward, when the bell moves forward, it pushes the air particles in front, creating a high pressure region known as compression. So we studied about this, right? High pressure region is compression and low pressure region is a rarefaction, right? Compression and low pressure region is rarefaction. Okay, these are the terms. When the bell moves backwards, a low pressure region is created which is known as rarefaction. The continuous formation of compression and rarefaction makes the sound of the school bell propagate through the air. Okay, so it is the combination of this compression plus rarefaction. These both together make the sound of the school bell propagate through the air. Okay, let's do one more question. Why are sound waves called mechanical waves? Okay, because they need a material medium for propagation. Okay, like air or liquids like water or metals like silver, right? It needs medium. What are mechanical waves? Mechanical waves are those waves which need medium to propagate. Okay, since these waves need medium to travel, that's why these are called mechanical waves. Let's do one more question. Suppose you and your friend are on the moon. Okay, will you be able to hear any sound produced by a friend? You tell. So on moon there is no atmosphere, right? What does that mean? That sound has no medium. Sound has no medium to travel, right? So, but sound needs medium to travel, right? So what does that mean? That no sound will propagate, right? So as the moon has no air and atmosphere at all, it is all vacuum, right? So sound cannot travel through it and we cannot hear the sound produced by a friend. So we'll meet in the next part of sound. Okay. So till then, stay safe and bye-bye.